Hi, today topic is generics in Java, and I would like to introduce the basics or fundamentals of generics and why they was introduced in Java 5th version. And basically the idea is when the first Java was implemented, the collection framework, it like for data structures and other collections like list, queue, set, etc. And when you start using the collection framework before the Java 1.5 or before the 5th version, it was some problems and issues, and for that reason they introduced the solution to use the generics type. Basically, it's parameters for classes, and there is some issues with Java class guest exception. Class not found. Class guest exception. Yeah, sorry. Class guest exception when you would like to enter some data to collection in any collection. If you have basic list data collection, you see now it's like in generics types you're able to pass the parameter for that list, which type data you entering to the list. Before this it was the raw types we import in Java util, and you just basically able to enter it, add any object to the list. We have the list, and we have the implementation of list interface, like for example array list. And when you're creating this array list, we able to add elements, and as you see here you're able to pass it object, and object is any type, basically any reference or primitive data type, you're able to enter it here. When we adding like numbers, like digits, we're able to add it like string, hello. We able to create a class, for example, like card, doesn't matter, for private, oh sorry, private string card or image real URL, for example, private string description, and we have the basic Java object constructor, maybe getters. We just creating some basic Pojo or plain old Java object. We creating the card class, and if you would like to pass it here card, able to create a card, any like new card, passing image, it's any URL address, doesn't matter, and description like a. And when we have like this object creation, we able to edit our object also to the list. And what's happening here, and when we have the raw type of list, we're able to edit any object. It's not a problem, but when you're working and you try to convert or try to cast your type, you will get class cast exception. For example, if you try iterate like list for list as doesn't matter, integer or card or any other type, if we have, for example, string s, and we taking the list as s. Oh, it's object, yeah. Because we don't know which type of list. Basically, by default is object, and now we able to do some conversions. Wow. We would like to convert our object as to string, for example, and our res equals s. And when we do like this, we need to cast to string, because we would like to read our list as a string list. And when we run in the code, we don't see any compiler issues, compiler errors. We're running our code, and we get some problems. As you see here, exception in spread, class cast exception, and integer cannot be casted to class Java language string. Basically, you get the problem when you casting the first element. If we just switching sides of those two elements, we will get later, of course. We're able to make that work. For the first element, we're able to print it out. For example, res, and to see the difference, we printed out hello because the first element is the string. We're able to do like this, convert our object to string because it here is a string. And later we try to convert the integer to string, and we get the runtime exception. And basically here is a problem, and whole collection framework was written like this, using only the raw type before 1.5. And in 1.5 they introduced generics 1.5 and later 1.5 Java versions, Java JDK, Java Development Kit, and later it introduced generics. And what they did, we just removed this problem for casting, because you never know which type you needed, and better you have the type display. You need to say which type of collection you need to create before the problems happen. And they rewritten all collection framework using generics. Basically, to fix this problem, nowadays you see that brackets like entering, for example, hello or any type like string. And when you're using this representation, you're not able to enter it or add elements which is not string. Basically, here a solution for class cast exception, and you see the compiler errors instead of runtime error like class cast exception, and it solves that collection framework will rewritten from beginning. And for that they solved, and also those generics created new way to write a code, because you're able to create the more universal code. You're creating the templates, and basically the class will get some parameters. when you have the method parameters, and class is also able to have some parameters and able to create generics methods and etc. How to create a generics? Basically, there is some names or naming conventions for class types, for class parameter types. Because when you creating like new generic class, you have to create any like new class. And for example, we would like to print it out any type we have it to console. Like just printed some numbers, integers and doubles or strings or chars or any type. Instead of basic solution, when you have the basic solution, I will show you two different approaches. Before Java 1.5 and after this when we're using generics. Basically, we would like to create our collection of any items, and we able to pick some name for our collection. We need some name like items, basically items, yeah, items holding some, or bag collection, which is holding some elements. And when you're creating basic class, you implementing the class bag, and we implementing object, and we need to create the template or universal code for our bag class, which is have the object, and we creating the constructor. We able to create setter also, and toString if we need it to return the object, and basically we're able to create some function, public void print result, system out print result by object, for example. And of course able to create basically any parameter, also object instead of object O, and maybe we print it out our constructor past object. We need to print this object, and we printing the passed object also. Pass it for print result method. Just show how it works. And of course here you're able to cast it to some object. Like if you casting like to integer, and you passing different object, you will get class cast exception. And that's reason why it's really was messy code. When you're working with this approach, you really get a lot of issues when you're casting some objects and when you're creating the basically templates, which is really greedy ones. And if I leave like this, we see some difference and problems maybe. I have basic bag class which is have object. We initialize this object, print result, we convert this object to integer, for example, and here we have some object passing as object, and try to work with this. And now we're creating our bag, new bag, and we passing object like integer, because we know that we casting to integer. And basically when you're passing object 2, that means your object will be integer. And now we able to set object. If you're not using the constructor, or you would like to change to some different object, and we print result, we able to pass any object. Like here is my object, we're passing some string, and we just running our program. As we see, our constructor passed object 2. It's fine because we casting to integer, and passing print result method, here is my object, it's working also. When we entering some information like hello, and of course we know that we get some class cast exception because we try to cast integer to string. Here basically you get some problems, and it's really not great. Of course we're able to remove this, and when you're passing some information, we're printing hello, here is my object. And if we passing here 5, you also printing the 5. As you see, if you want the char, maybe we create this backslash, for example. It's working like as a template because you're able to pass it any object, and this object basically will work as you intended as a char, for example. When you're passing the char, you will able to passing as a char, string, and it's no problem here. But when you're writing some algorithms, for example, you would like to passing only digits, numbers, or something, and you need to calculate. Of course, without the casting, you're not able to make some arithmetics, like if you would like to say that int res equals object plus 2, because in Java there is no overloaded operators, and you're not able to sum up object plus 2, for example. There is no expressions, because you need to say that here is integer. And if here is integer, yeah, it's okay, you're able to do like this. But here you face you back to the problem, because we're passing a char, and when you're passing the char, you get the class cast exception. Like it's not the best solution for our case when we need a template. And whole collection framework basically was without this generics. And after they introduced it to generics, they also suggest to use some class parameter names, because you're able to enter any name, but it's easier to have the single element, single char for representation of the parameter, of the class parameter. And basically E is for element, key is key, number, type, value, and etc. if you needed more. And now I'm creating the same bag class using the generics. Bag generics. And when you're creating the bag generics, you're able to add a parameter using that bracket. And here you're able to pass it, as I mentioned, any name like hello. Basically, it represents the parameter of your object. But instead of this, I recommend to use T if here you need a type. And down below, you're able to create the type instance. Basically, T means the same object. Any type. When is T just a T? And here you're able to create basically the same constructor, getter if you need it. Oh, sorry, I'm back here. Back generics. We're creating getters. To string, I don't know, it's not needed maybe now, but and we just able to create the same method. Print result, for example. Sorry, we need to add void print result. And when you're printing a result, you're able to pass it also T. If you needed the class T, basically it's object here. And when you compiling program, it clears those parameters and change this type which you passing to this class. And print result T, you're able to print it your field, maybe final. This T, because we need that one from constructor, for example, and we need to print it other T from parameter. Constructor, this T, and we just using that inside parameter T. And now we try to use our bag generics. I'm just commenting here. And bag generics, basically you're able to create a class as you want without generics. And as you see here, object T. Basically, when you're creating the T, able to pass the object. But here, if you're using as a raw implementation, but you back to the problem class guest exception. Instead of this, you need to enter the parameter which type of T will be. And here you need to pass, for example, string. And for constructor, you need to pass parameter, of course. And as you see here, if you enter in the string, it will be that automatically casts to string, and during the compiling process, you will get the errors if you have some errors. Instead of runtime exception, you will get just compiler error and you're able to fix the problems. And here, as you see, able to pass the string. Yeah. It's constructor parameter, and it will go like hi generics working. And now we're able to create different back generics. I don't know, just back 2, 3, and we're able to pass the card, we're able to pass the integer, but you're not able to pass the primitive types like ints, like this, because you need a wrapper class. It's only the reference type you're able to pass in here. Here is a problem. You need to use only uppercase classes or wrapper classes. And as you see here, we get only single one is working here because here parameter is wrong type. Here is a card type, but we passing string type. Here is the integer, we passing that string. It's also not correct, and you will get some errors. You're able to pass it like number, and here you're able to passing only the class like card. And card is basically that. And basically we created our generics class using the single parameter, and when you say that string, you mean that your T will be that string type, card type, integer type. Like when you're passing here, compiler changing after this, after type erasure process, it will change to your type, for example string T or any type later. And we need to print results. We're able to print results here. Back generics, print result, and as you see here, we need to pass parameter string. Hello. And when we using back generics 2, we need to use, as you see, card object, new card, passing card piggy, doesn't matter, just new card, just some information. And here we able to use it back generics 3, and as you see here, string card integer. When you're choosing here, it shows we need to pass the integer because here is the integer. And basically you create a template. Those generics basically was for class cast exception problems, but to be able to create your own collections, etc., or algorithms which is able to control your parameter passing. I later show what you're able to do with that letter, because sometimes you don't need it all types. You need that some types like digits or letters or some card type only, and etc. Able to control which types you're passing. And when we running this program, you will get some output. Constructor, first, hi, generics working, and we print result passing the string hello. Constructor have empty card, and we passing the card with some description. Constructor have 54, and we passing 444, just like this. And here is basic usage for generics. When you're using in the classes and you have the basic the mirror of this implementation here. Instead of manually casting, it's automatically casting and solves the problems with class cast exception, because you will get compiler errors when you're using generics. But if you would like to create a generics class which is able to take only the, for example, string, instead of back generics t, you're able to write a keyword extends string. And when you're writing t extends string, that means you're able to use only the string and you're working with the string type. And as you see here, you get the problem because the type parameter card is not within the bound should Java language string. Basically able to make the bounds like for here. And sometimes maybe you need to add it other types also, like you're able to pass that string type and you would like to add it some interfaces also. For that reason we created interface card shuffle shuffle, yeah, interface representation and void shuffle. For example, we have the shuffle interface which have only a single method shuffle, and if our card have implements shuffle, we implementing this parameter shuffle void and just system out shuffling, or just some method for the card class. And instead of string, I would like to use in our back generics to use our card type, and instead of column symbol of comma symbol, because it separates two parameters, able to create e if you would like to use the another parameter like private e. And basically when you have the map data structure, you're using two parameters, like first parameter and second parameter. And also you're able to have two parameters, three parameters, or any amount of parameters like this. And you're able also say extend, string, doesn't matter which type of parameters. You just basically in generic classes you have not two or three parameters maximum. I don't know, to have more it's really too complex solutions. Basically use the single parameter, two parameters and three parameters. It's really rare or unique situations. I don't know, it's possible to use three parameters. Yeah. And if you need to say that t extends card, the bound for this t letter, I would like to say that t extends card and card should be the I interface. Instead of comma symbol, you're using and symbol because there is no any other symbols to make that representation of two types like card and, for example, I shuffle. And if you need more interfaces, you're able to add it or more interface and runnable and any amount of interfaces. And t extends card and I shuffle. And if this generics passing different type, not card and shuffle, you're not able to pass it here. And as you see here, here is a card and it implements I shuffle. That means you're able to use this representation, able to pass the card object, but you're not able to add integer and string parameter. And now we're moving to the next stage. Basically here you're able to control the bounds for your generic types. And when you have these types, you're able to easier control your T letter. Because your T is card and I shuffle, you're able to work with that type methods. For example, T get description, T print. Oh, it's any methods inside that card class, like int sum, int a, int b, return a plus b. And when you're working to generics, basically using the same approach when you just implementing sum. 2 plus 2, for example. You're able to work with the normal objects, and you know that T is you don't need to cast, it's automatically cast to the card. You don't need to write like cast like card. And yeah, basically you get the reference and you're able to work with that reference. And if you passing here integer, you're able to work with, oh sorry, T extends integer, and now T is integer. You're able to make some calculations like int a equals T plus 2. Oh, now we see the problem. Operator plus cannot apply to T, or maybe it's this T. No. Yeah, here you need to int value, because there is no other solution, because here is object reference. Int value methods returns integer. Able to return any other primitive types if you need it. Because the integer is the wrapper class, which is wraps the int value. Yeah, and we're using the int value, or this if parameter from here. Basically, that's it for those generic classes parameters. You're able to extend and use interface. That's it. You control your type, which type will be the T letter, or just any other letter. If you're passing here E and using down below like E basically object, able to also extend as the string. String, and then you're able to say that string my text equals E. Because the E is the object reference, there is no problem with like this primitive types. And my text will be the E as a normal. And basically that's it for the class parameters. Now exist some generic methods. Basically you don't need to create any class. You're able to create generic methods anywhere, like here, main. You have the overloaded methods, if you know that when you're creating like public static voids, because we're working in a static context in the main, it's better not create the instance. We have overloaded solution, for example, print int a, for example. You're able to create another method which is have different parameters. Double b, print char c, for example. Here is normally called as overloaded methods, and as you know, the constructor also have able to write the three separate different constructors using the same name. Basically, it's using also that overloaded method. And print a, print b, print c, and we're able to add it more if you needed more overloaded methods. Have some parameters int a. And basically overloaded methods, it's dynamically calls which parameters you're passing. And now after main, we're calling this function, for example, print a. And as you see here, a lot of group of different methods added. Which one you're picking, that one it's automatically printing. Print char r int o. Yeah, here is basically overloaded methods. And generics also introduce the generics for methods. Because why not to use it somewhere? When we're fixing the collection framework, we're able to use it somewhere. And we're able to create also generic. It doesn't mean that we don't need it, the overloaded methods, because we still needed those, but we're able to combine generics and overloaded also methods. And how to make it generics? Basically, you enter the modifier first, then you enter any letter, like as in the class t void print. We implemented generic print method, which is using t, for example, and we able to use as overloaded method also, because we already have some different methods, but we're able to use it also our custom object. Basically, t the same as object, but you don't need a cast. And here the rules the same as a class, like extends card, for example. And I shuffle. Basically the same rules for methods also as the class. He will say your t will be as you see the card class, because we get description, get image URL address, get sum, and etc. And you're able to make it any of type for your print function. For example, you just creating system out and you're printing the t. Instead of card, you just have the t and you printing any object you will passing. And of course now the strange result will be maybe when we printing hello, it will print hello. If we're calling print one, maybe it call that one. We need to check this. Yeah. And as you see here, hello, because there is no any other print with the string parameter. Basically, when you're using overloaded and using that generics, and as you see, if using the single parameter, which is any type, basically you don't need those three methods. We're just deleting those three methods. Instead of those three lines, we're able to print it one also when we're using that generics approach. Basically, it reduces also for overloaded methods in some situations. Instead of creating like char int char, or it doesn't matter which way you would like to create that print method, you're able to make it also other generic type, for example t, e, and instead of this you're just passing tt and e, and just now you're able to passing any parameters e, yeah. And basically when you're passing a and e2, you will print two parameters like a and 2. As you see here, when we have those, we have already also overloaded, but of course you need to control, like, I don't know, for the first parameter you need, for example, digits or some numbers. You just see number. And as you see here, you're not able to pass the char any other object instead of number class. And here you're able to pass any number. 29, 2, I don't know which more numbers, integer, float, long. Yeah, you're able to add it any like long, L, basically any number, any type from the number class. E is any other parameter, doesn't matter which type. You're able to pass like new card also, because first parameter is number, other parameter is, doesn't matter which one parameter. And basically here you just reduce the code when you're writing overloaded, but then also using the generics types, and you will get the problems, compiler errors, if you make some wrong input to this parameter. Yeah, and basically able to create universal solutions or methods. Basically you're able to create sort algorithms for any type if you would like, using generic also, or just create. Basically it's more oriented to create the generic collections, generic interfaces, and those interfaces also introduce it like as lambda expressions, have a lot of interfaces. Like when you're working with the lists, you're able to see the implementation of list interface. And as you see here, public interface list is have parameter e, because we have the some element and extends collection class, which is also generic, is also E. And we have int size, boolean, contains, iterator, object, and here you see T, as you see, the method which is returns T array. It's any type array when you call it to array function. We have also boolean add, and you see here we're adding element E. Just any element we adding to collection. And basically remove objects. Here you see question mark, basically unknown type. We later talk about wildcards. And here as you see, wildcard with collection extends E. That means you take that element type, parent class and child classes, and remove all, and etc. Like there is a lot of implementation using that E, because you're able to create, iterate, for example, or change all elements inside that collection using that any type. And there is a lot of different interfaces also. Predicate, for example, you're able to see public interface predicate. It takes T because it have only that T parameter. You're able to pass any parameter instead of creating 10 different interfaces. Better to create a single interface and passing any parameter which returns true later. You're just passing some logical condition, and you're able to get result true or false. Basically, you need to pass it predicate. And that's it, where it also used the predicate for and, negate, and also or, is equal, and not, because in new Java interfaces you're able to use default and static method also. Here's the util functions or methods added to interfaces. Okay, and now we're moving to the wildcards topic. Basically, wildcards, it's not a big deal when you're working with generics. Basically, you have parameters, but sometimes you need to control the parameters which is inside already implemented collections. Yeah, it's really strange, and sometimes it's really hard to understand where you need to use it. You need to have a larger inheritance example to work with wildcards, or just when you're using the list, for example, and you're having the list which is passing some hierarchy or of inheritance. And instead of writing like string type, maybe we need to create some classes. Okay, I create a class parent, maybe like this. Yeah. We have the class parent, we have the new class child. Child extends parent, and we need other class, Java class other child. other child extends parent, and maybe the parent also main, no, not main, parent also have some top class, and the top class will be, okay, top class, for example, extends, or no, parent extends top class, and top other child, others child, and maybe we need one more class with this lower class. Child lower class, maybe. Lower class will be the lowest class, top class will be the top class. Maybe we bottom class, rename it to bottom class. Yeah, bottom class. Bottom class. And bottom class, it's connected to child, for example. Yeah. And now we're able to draw our diagram. Top parent, other child, child, bottom class. Create diagram, show diagram. Yeah. And we have like top class, parent class, child, other child, bottom class. We have some hierarchy here. And when you have wildcards, you're able to control, like, I would like to take only the parent class and top class. Or I would like to take parent class and child classes, like child, other child, bottom class. Like this. Basically, when you have the list, you're not able to say that. Or maybe it's possible, I'm not sure now, but you're able to control the classes to say like child class and all parent classes. Yeah, you're able to control like this. I need a child and parent top class, basically. That hierarchy here. And if we have, we need to make snip here. Snipping tool, now opening the main, and we just try to write some code. Basically, wildcard topic is really hard to understand when you doesn't have the real example. And now you're able to say that lower bound or upper bound or unknown types. Like when you have the list, you're able to say that list is unknown type. New array list. Basically here means that unknown type for your list when you're calling this add, and you see we need capture of question mark E. When we passing, for example, hello, you basically need to call to make here string. Not working, yes, as you see. Because unknown type, it's really you're not able to make any. You're not able to entering anything here because basically here is unknown type, that means. And instead of this, I would like to say that wildcard is string. No, it's not a key. You're able to say it only extends string, and we see the problem also exists. Why it's not? Maybe super. Yeah, super. Sorry. Super and extends, two different. It's lower bound and upper bound. Super means upper bound. When you take that class like string and all classes up to string, or no, maybe we need to check wildcard. Sorry, maybe I take that representation. When you upper bounded wildcard number class. When you're writing the super, it means you take that string type and you go down, like it will be lower bounded. When you're using the extends, it will be that upper bound. That means you're taking all classes up from string. That class basically doesn't have the parent class, and for that reason it has only the object maybe class, but for our case it's wrong type. We need to use the super. Okay, here is with the string. Now we're creating the list using our hierarchy, top class and parent class. Like super and child. Child equals new array list, for example. And child add, we able to add, we just testing here. If the super is the super classes, we able to add a parent. No. New bottom class. Yeah, it's super class. Yeah, sorry. Super class means that we taking lower bound. It's really a bit messy here. Lower bound. That means we go from current class down below. Super means lower bound, that we go from the current class, from this one, down. Yeah. Down, that means the child have only the single new bottom class. And if you try to add new other child, you're not able to do, because it from different hierarchy from here and is not connected to down side. And here you're able to use only the bottom class. If you changing this to upper bound, you need to change super keyword to extend. child's upper. And now, as we see it, it's still working. Oh, because it's child, sorry. Child's upper. Child's upper. Yeah, and now we not able to add it child bottom class because it's not upper bounded. That means you're not able to see this class. You're able to see upper classes. You're able to pass it maybe new child. We try no. Itself we can't. We try to new other child. No, it's not working. New parent. No, it's also not working. Which classes will work? Top class? No. Child. Maybe we change to parent. New bottom. Not working like intended. When you have the parent with upper bounded, really some problems. I don't know what's happening here. If we use the number instead of this. New integer. No. Not working. New number. Oh, it's... I need to take the example here. List extends number. Okay, let's try this. Because here are some problems. I don't know what's going on here. Here we have the sum of list. We basically summing, try to sum up double values. Arrays. Basically here you see we able to passing a list of integers and doubles to our case. When you have the parameter as a wildcard, we passing like numbers. We passing the numbers to the sum of list. But why not working that this one? I'm not sure now. If we changing here to, for example, child, return static double, doesn't matter, any return. We creating our sum of list with which extends child class. That means is upper bound that should able to take that parent and top class. We need to check here. If we would like to passing some array of parent. LD, oh sorry, yeah, array list as new parent, for example. Strange results with that casting. Maybe it's not working or it works. Unchecked cast. Let's try to run it. No, not able to cast. Okay, we try to make the child. Oh, child is working. Child is working, and if we passing bottom class, it should also work. Yeah. But now when we using parameter extends, basically it takes child and bottom class. It's really those wildcards. It's really some messy way when you're using in the list like here, and you're adding elements, and when you're passing the list. Basically, I think that you never use that wildcards. Be able to use like this to control, like I able to pass that super string. If you really have some hierarchy, you're able to control like this. But basically, I know better approach when you have some functions or methods when you really need control. Like when you have some class, inside that class, you decide that your T will be a bit different one because you need to control. And that wildcard, when you're using like here, I don't know, it's really facing some problems. When you have some method like this, you're able to control normally. When you have this method, you're able to control a generic type instead of using the default one. When you have, for example, back generics, and we're creating, for example, new method, public void, and you don't want to create this generic method, and you would like to use the T list output, and you're using the T list, for example. Sorry, import to till list. And here you decided I don't need all types, or like, yeah, here is integer, okay. But if you're able to, if you're passing any type here, you just say, oh, maybe I use the wildcard, which extends. You're able to see the T, of course, you're able to extend some string. Yeah, but now it's really hard to see that usage at the moment. But you're able to control that upper bound, lower bound, which is passing here. Because you're able to get methods and those types to control it. Basically, if I write extends child, I'm able to pass parameter, as you see here, bottom class or child. When you're writing extends, if we're writing the supper, we try to see which types we're able to passing here. Oh, it's child, also child, supper child. We need to change this one type. Parent, for example. You able, as you see, to pass it parent class, top class maybe. Top class is also okay. And yeah, top class, because the bottom class is also extends from that hierarchy. Maybe sum of list, how to create a list of, for example, parent. Parent, top class, all classes will work here when using supper. It's like from here to top. If we try to create other child, it not will work because it's not from that hierarchy here. And basically, as you see here, we get the error. Of course, it's not other child. Yeah, and basically you're able to control using wildcards those parameters, which types you're able to pass it here. Here is the more examples how to use those. For example, you have that the last one for today. We just would like to print objects. We're creating two methods. Upper bounded wildcard number class ir kitos veiksmės. Here you see the print list, and we passing wildcard like question mark. That means you are passing object, or you passing unknown type. And here, as you see, we iterating through the 4 object element list, because here it's unknown type, is object, and later you able to print it. Just we try to print it here. I'm deleting here. Integer array list 1 to 3 and array 1 to 3. And now I'm running this code, and you see that result will be printed out as normally. As you see, that question mark basically the object also. If you're using the object, but it's wildcard. Yeah, but if you're using the object, you see the problem. Require type list object, we get list integer. That means the object not work great like the wildcard here. When you add a wildcard, basically it lets you passing any type because it takes unknown type as a generic type and then converts to that type which you passing here. It's really complex complex stuff, but question mark basically similar to object, but as you see, if you're passing the object parameter, you need the object parameter. If you don't know which type of list you're passing, because maybe you're able to create dynamically that list, and you passing this list, and then you're able to work with that list. Basically, the wildcard solves this problem when you have that question mark added here, when you don't know which type of list you're passing to this parameter. This wildcard, it's really easier to understand than other wildcards, upper and upper bound, because when we using in here, we saw that lower bound it's like from this class down below, and upper bound will be different way. But when we passing, we see that not working like intended, and yeah, maybe need more real examples to work with that. And yeah, lower bounded, super integer, we are able to work with integers. And when you work in integer type, you're able to take integer, number, and object. Basically, you're working with the top hierarchy of integer when you're taking the super. Super means you take that current, like integer, then number, and number class also have object. You're able to pass it all those three when using super. When using extends, it should be working different way. And here, as you see, the also generics, you're able to classes work like t extends other generic inside that parameter. It's a really complex one. And there is some type erasure which clears your code later. Maybe I need to open it, or maybe I don't need here. Basically, when you have that parameter, you have, for example, t extend shape. After type erasure process, compiler get basic method like public static void draw, and inside parameter instead of t get shape. That's it. Automatically casting types which you're passing, and automatically clears that unused text and make the normal methods, the type erasure process with generic types. And there is a lot of exceptions, and when you try to make some generic universal code. You're not able to use primitive types for parameters, and you're not able to, basically you need to know that you're not able to create a static T or types, type parameters, because when you're creating different objects and passing different types, you never know which type is real for that static type. It's smartphone, pager, or tablet PC. For that reason, you're not able to use the static as a static keyword. And if you're using, you will get some problems because you don't know the smartphone, pager, or tablet PC is T, and static should be fixed value. That's it for today. Thank you for your attention, and if you have some questions, please ask.